more you go back in time in Bitcoin, the more secure the blocks become. If you think about Bitcoin, like it's a humongous asset, but it is mostly sitting there. It doesn't produce any yield. While on the other hand, you have proof of stake chains, which are in need for economic security. The more, the better. Ideally, we would like to provide the Bitcoin security for chains at the next block level. So our goal is...
Welcome to the Bare Metal Podcast.
Hello everyone, welcome back to the Bare Metal Podcast. Thanks for tuning back in. I'm Ship the Code from Rockaway X, your host, and today I'm here with Vitalis Salis of Babylon Chain. Very much looking forward to this episode. Welcome, Vitalis.
Hi, thanks for having me.
Thanks for coming over. So I think Babylon Chain has been on Twitter quite a few times, but I'm not sure if everybody is aware of what was the purpose, what is the purpose, and what is the project. Like, can you introduce yourself, how you came to participate in the project, and what does Babylon Chain do?
Yeah, for sure. Yeah, so I'm Vitalis, and I'm the lead engineer at Babylon. I was one of the first engineers that came to the project when it started out a little less than 2 years ago. And my thing is coordinating and participating in all the efforts, ranging from core node development, the peripheral programs, backend infrastructure, and sometimes even frontend. So what Babylon does is, in one sentence, we are creating security sharing protocols between Bitcoin and the proof of stake wallet. Our flagship protocol is Bitcoin staking, which is basically a protocol that allows Bitcoin holders to trustlessly stake their Bitcoin to secure proof of stake chains and in exchange get proof of stake yield from them for their sellers.
That sounds really exciting. I'm anytime I hear BTC liquidity and considering the market cap, bringing that to the rest of the ecosystem just sounds like a really interesting proposition. I'm excited to get into all of that. But first, I'd be interested in understanding, how do you guys start, Babylon Chain? It seems, I don't know if there's a project like it. It just seems sort of off the charts. What was the original idea? What was the inception?
Yeah, so when we started out, we set out to solve the long-range history revision attack problem. So this problem basically these kinds of attacks take advantage of the fact that a proof of stake chain actually gets less economically secure the more you go back in time. Because the more you go back in time, the more you run the risk that in a past block, a validator that had voting power back then is no longer bonded and therefore no longer slashable. So to solve this, we developed the Bitcoin timestamping protocol, which is basically a protocol in which we create concise and provable timestamps of the POS chain, and we store those timestamps on the Bitcoin ledger. And those timestamps get more and more secure the more you go back in time, the deeper they go inside the Bitcoin chain. Because Bitcoin actually has the reverse property. The more you go back in time in Bitcoin, the more secure the chain, the blocks become. The more difficult it is to reverse them. And
a quick question in here?
Yeah.
So when you say start in the ledger, do you actually execute the transaction in Bitcoin that in the memo field or in the sort of field for the opcodes, it somehow contains a special message that corresponds to this timestamp that you guys are storing? Can you sort of tell us more about how that works?
Yeah, exactly. You got it right. So we are utilizing the op return field of the op return script code, which basically allows someone to insert up to 80 bytes of data inside the Bitcoin ledger. And we create two such op return fields in two separate transactions. And yeah, it was actually like a pretty hard job to try to get all of these concise and all of this data to make a concise and provable timestamp inside such a little amount of storage.
So 160 bytes in total. We're talking 2 TXs, they're connected together.
I think we are using 148 bytes to be precise.
Okay, 148 bytes. So that's where you store a timestamp that indicates, that somehow contains in it some sort of validator state from the other chain. What's stored inside this timestamp?
Yeah, exactly. So let me remember exactly the kinds of data. So of course we need a unique identifier for the block that we are timestamping. I think that's 32 bytes. We need signatures from the whole validator set for that block. And to do this, we utilize BLS signatures because they are aggregatable. And I think this is 48 bytes. We also contain an address, because we want to incentivize the entities that create those transactions to include the data into the Bitcoin ledger. So that's I submitted it. I can get rewarded later by the Babylon chain for providing this service. And also a bit field. These are the ones that come directly on top of my mind.
Okay, so you had to design a format that would allow you to encode all of this into the, let's say, less than 160 bytes, 148 you were saying, and that gets committed regularly onto the Bitcoin blockchain. It's sort of building a mirror history of the POS chain on the Bitcoin blockchain. Is that a fair?
Yeah, exactly. We do it every epoch, and in the current testnet, an epoch is 1 hour.
Every 1 hour. So you're sort of, okay, you're checkpointing the chains with every 60 minutes history. Okay, so you guys started with that. Was this motivated by did you feel that the long range attack problem is like something that blockchains are concerned about, that nobody was solving it, and that's why you elected to start with this one, or
Yeah, but this was an open problem that our research team at Stanford was very interested in. So yeah, we started out with this. We think that this is a real problem, and like most proof of stake chains suffer from that. And up till now, proof of stake chains were solving this using social consensus, which is a big reason why, for example, in Cosmos chains, you see very long unbonding times. It's actually to protect from these kinds of attacks.
So one effect of using this timestamping protocols would be that you could reduce those unbonding times?
Yeah, exactly. So we, in the current Babylon testnet, we can probably reduce the unbonding time in a secure way to 16 hours to 1 day, depending on how deep you want the timestamp to be in Bitcoin in order for you to consider it secure.
Well, that's a pretty interesting proposition. But so was there uptake from the blockchains? Did they find this proposition attractive? Are there any users of this idea now?
Yeah, so earlier this year we launched a testnet in February, and the Cosmos ecosystem really liked this protocol. And since we launched, we have seen more than 35 chains integrate with Babylon. And so basically in this testnet, Babylon acts as a timestamping aggregator. So chains connect to Babylon, and Babylon creates concise and provable timestamps for them. And we have had around 35 chains connecting to us. We connect to the Bitcoin mainnet, and these chains get Bitcoin security from their connection.
So now it's making more sense in my head, because I was wondering, when you say the signatures inside the Bitcoin TX are aggregated, somewhere you have to keep the source. So Babylon chain is the one that's keeping the long form of the signatures, let's say, around, and then the aggregate signature gets stored in the BTX, in the BTC TX. And is Babylon chain like the intermediary that stores let's call it the unpacked, non-concise, original long form data that the chain submit, and then the data is compressed and the signature is stored on, or like a signature of the data is stored on the BTC chain? Would that be a fair summary?
So what the signatures are about the Babylon block. That's at the end of the epoch. So those are block signatures.
And that's why you can sort of certify all of the chains that are using Babylon at the same time, because you're actually committing to the Babylon block, not necessarily, not to the individual blocks. I did not understand that. I see. So the Bitcoin timestamp corresponds to the Babylon block, and the Babylon block contains transactions from other chains, coming from other chains that actually encode the data you want to commit to.
Yes, exactly. So through IBC, Babylon maintains light clients to the other chains. So the headers of the other chains are committed to Babylon, and then a commit of the Babylon header, a signature of the Babylon header goes into Bitcoin. So through these signatures, you can get the Babylon block, and through the Babylon block, you can get the headers for the other chains.
Right. Yeah, it makes total sense. Very interesting construction, very scalable, right? I mean, you can add more chains. So, are you guys still actively developing this feature now? Is this what you're focusing on at the moment?
Yeah. So we worked on this protocol, for a long time, and and the testnet works. We have seen that it scales, but we didn't want to stop right there. So you see, with Bitcoin timestamping, you get Bitcoin security, but at a slow pace. So you need to get included in a Bitcoin block. The timestamp needs to get included, and it needs to get deep enough inside the Bitcoin ledger in order to be considered secure. And this is much slower than the block production rate for a proof of stake chain. So we want it to be faster. Ideally, we would like to provide the Bitcoin security for chains at the next block level. And we thought about this problem, and to solve it, we had to look at Bitcoin from a different angle, not as Bitcoin, the time stamping server, but as Bitcoin, the asset. So if you think about it, Bitcoin is a humongous asset, like more than $700 billion at this moment. But it is mostly sitting there. It doesn't produce any yield for its holders. While on the other hand, you have proof of stake chains, which are in need for economic security. The more, the better. So what we did is we connected these dots. So we connected these two problems. And we came up with the Bitcoin staking protocol, which is the first protocol that allows Bitcoin holders to trustlessly stake their Bitcoin and get voting power in proof of stake chains in order to secure them and increase their economic security. And in exchange, proof of stake chains reward them for their service.
This sounds, I'm excited to dig into that. I'm really interested in how that works. But first of all, I want to ask, what was the reaction of the Bitcoin community to this? Because I've heard a lot of sort of different factions inside Bitcoin, and like one big faction is leave my Bitcoin alone, like it should not be used anywhere. Have you guys had any interactions with this type of people? Have you had some pushback from the Bitcoin community?
Yeah, we're actively talking with Bitcoin community members, and the thing that most Bitcoiners care about is security. So right now there are solutions for getting some yield for your Bitcoin. There's wrapping, bridges, third-party custody, but Bitcoiners do not want any of that. So the first thing that Bitcoiners ask us is, okay, who do I have to trust? I don't want to trust anybody. Get out. And we tell them that actually with this protocol, the Bitcoin never leaves your wallet. It's you do not give up any ownership. It's still yours.
That's really interesting. So unpack that for us right now. Let's get to the meat. So you're saying I have a Bitcoin wallet, and the Bitcoin wallet has an address, right? And I'm storing my one Bitcoin on the chain, and now I can somehow stake it on, let's call it the hub, right? Let's, for example, think about the hub chain. I can stake it on a validator in the hub chain. So I think that's a very complex protocol. I would suggest let's break it down into two perspectives. Like the perspective I'm most interested in to begin with is, how does the staking happen from the perspective of the guy holding the Bitcoin? So what do I have to do? Because the Bitcoin has to become slashable. Am I right? Somehow.
Yeah, exactly.
So how do you do that?
Okay, yeah, that's awesome because you already got into the two most important properties that we want from this protocol is trustlessness and secondly slashability. You can't have an asset that is not slashable. Just to mention them, other properties that would be nice for Bitcoin as staking asset is restakeability. So you lock your Bitcoin once and in exchange you get voting power in many different chains, and also some UX features like you get voting power and you can delegate it or you can unbond on demand. So how do we do it? We do it through this kind of hard because Bitcoin scripts are very limited.
Right?
Yeah, they don't provide any smart contract functionality. So we had to come up and utilize and combine two very important pieces of our technology. The first one is our Bitcoin Staking Script, which is a script in Bitcoin's scripting language. And the second one is extractable one-time signatures, which is a cryptographic mechanism that basically says you have a private key, you can create derivatives of this private key that can be used for signing, but you can only sign once using those derivatives, only a single piece of data. If you sign two pieces of data, then your private key gets exposed. So these are the two core components.
So if the mathematical cryptographic properties of the signing scheme are such that if there exist two different pieces of data that are signed with the same key and an attacker has access to both of those, they can automatically reverse engineer or retrieve the private key, and therefore there's no longer secure. I'm not familiar with such schemes because that's interesting. Okay, so one time. So we don't lose focus.
Extractable one-time signatures.
Extractable one-time signatures is one piece of this, and then the staking script is the other piece. So can you take us through this sort of in order?
Yeah, for sure. Okay, so first let's see how staking happens. So the Bitcoin script in its simplified form, and we can expand later if you want, is basically a script in Bitcoin scripting language that basically says the following. I lock my Bitcoin, and my Bitcoin can be unlocked in two different ways. The first way we call the time lock path. And this path basically says I can unlock my Bitcoin after a certain period of time, let's say 3 months, 6 months, 1 year. I set it in advance. And I can unlock my Bitcoin in its entirety. And the second path, we call the slashing path, says I can unlock my Bitcoin right now, but I can unlock only a certain portion of it, while the rest are going into a burning address. So both of these paths only require my approval, require my signature. So they are still completely in my control. I lock my Bitcoin, but I don't give them to somewhere else. I still maintain full control.
I'm wondering how the time lock is implemented, but maybe let's maybe dig into this later. Let's talk about the other path, right? So I'm guessing there must be some sort of oracles involved or some sort of transfer of information involved now, because on the post chain you have to identify that there exists some locked Bitcoin, and this Bitcoin is actually staked to some particular validator or set of validators, I guess. And then somehow we also need to get the slashing information. To be able to communicate, credibly be able to communicate this information back to the Bitcoin chain, so I can actually be slashed. So if we look at this from the other side, can you unpack this then? And how is Babylon chain involved, right, in this sort of transfer?
Yeah. So just for the time lock, it's just a single script command in its in the Babylon scripting language. So it's a time lock in terms of Bitcoin blocks, not time, but given that there's an average of 10 minutes, we can calculate approximately how much time that is. Mm-hmm. Yeah. And what was the question about the slashing part?
So the other part was, if we look at this from a Bitcoiner's perspective, okay, I don't give up my Bitcoin, but I have to execute a special transaction. I guess that's on chain as a UTXO, like so it's like an unspent transaction output.
Yeah, it's a transaction that
run one of those two paths. Okay.
Yeah, it's a taproot transaction.
And okay, now if I look at this from the other side, right, as a Bitcoin owner, I've done this, but now somehow there must be infrastructure on the other side of this, which picks up that this has happened, right? Mm-hmm. And somehow, like can you explain how Babylon chain is in the middle of this, and how does the target post chain, what integration is needed, or how does it even learn that some Bitcoin is locked and it's staked to this guy, and how does it get slashing information back? So sort of like, that's a big question, but let's take it through, the steps. How do you identify the Bitcoin's locked, and to whom you are staking?
Okay, yeah. So like Cosmos chains have IBC relayers between them. We have developed relayers between Bitcoin and Babylon, which we call vigilantes. Mm-hmm. So these vigilantes, they are called vigilantes because we require, it's like a service to the network, and we require only one honest person doing it. So that you are providing a good service. You are a hero for us. So this vigilante's responsibility is communicating information between Bitcoin and Babylon. And Babylon actually inside it maintains an image, a light client of Bitcoin. So this is why, this is how Babylon knows what's happening inside the Bitcoin ledger. So the only thing that the staker needs to do is to send this transaction containing the Bitcoin staking script to the Bitcoin ledger, and then let Babylon know, hey, I have sent this transaction to the Bitcoin ledger. It's in this block. Check yourself. And Babylon goes and Babylon checks and like, yeah, it's there. Okay, all good. You have staked your Bitcoin.
Okay, so now Babylon chain knows that the Bitcoin was staked, but you didn't mention the original transaction doesn't talk about where it is staked or to whom it is staked. So does this happen on the Babylon chain?
This is part of the script.
Okay.
So the staking information is a part of the Bitcoin script. So
I see.
The amount, the time lock, how long I have staked it for, who I have staked. Did I stake it myself? Did I delegate it to someone? Yeah, this.
So the operator address, is part of the script.
Yeah, exactly.
Which also identifies the
chain. Bitcoin public key.
Mm-hmm, mm-hmm. Okay. So now the Babylon chain is aware that there are Bitcoin tokens staked to a specific validator address, let's say on the hub, right? I pick a random validator, I stake over there.
Yeah.
But the hub still doesn't know that has happened, right? So the hub is now, there's no integration that has happened that I understand yet. Babylon chain is aware of this. Now, so now is Babylon chain also responsible for to decide when to slash or like how do, and where do the rewards come from? That's another question.
Yeah. Okay. Cool. Yeah. So currently we have developed an MVP in which this works for Babylon. But the design, I'm saying this because we have not implemented this, so something might change. But the idea is, the design is that Babylon propagates this information to the hub in a provable way.
Mm-hmm. Again, via IBC?
Much like the Bitcoin timestamping protocol. Actually, the chain that connects to Babylon doesn't have to trust Babylon. This is very important for us. We do not want chains to trust us. They are not getting Babylon security, they are getting Bitcoin security. So this means that Babylon propagates this information along with the necessary proofs that that the chain can use to validate that this is indeed happening on Bitcoin.
So the target chain will be able to determine that there is a UTXO inserted in the Bitcoin ledger that contains this information and really actually understand. Okay. And then let's say the slashing or reward logic will be implemented on the target chain. So now you're saying the MVP is on Babylon chain. So the Babylon chain as such picks up this information that there's extra stake on some validator, and this is sort of this is picked up by the rewards distribution module. Is that the way
So
this works?
Yeah, rewards is another open thing. So in our MVP, we wanted to prove that this works. So what can happen is a certain portion of rewards that are minted by the protocol, a small portion of those can go into the BTC stakers. So
and they will be ascribed to them on the. They will be ascribed to them on the Babylon chain, right? If we're talking about the Babylon MVP, the rewards are going to appear in like a Babylon chain account.
Yes, exactly. Yeah, so you connect your staker account with your Babylon account, and the rewards are going there.
And the rewards are going to go there. And I guess so when, if there is so now I'm trying to piece this together. If there is a slashing event, if Babylon chain determines that this validator on whom the BTC is delegated has been slashed, it will send a transaction, it will send another transaction to the Bitcoin chain that will activate the path, the second path, the slashing path of the UTXO.
Yeah, but the question is, how is Babylon? How can Babylon send this transaction to slash someone?
Yes, that's definitely a question. So, but among the two of us, I think you will have the answer. So, like, hit me.
Yeah. This part really excites me because I think that's the smartest thing about our protocol. So, yeah, basically, if you recall, in the beginning we said, okay, like only the owner can execute the paths. And we also discussed about extractable one-time signatures in which your private key is exposed, which is, that's the hint right there. So what happens is, okay, you stake your Bitcoin, you get voting power, Babylon knows about it, and okay, I can start voting. But before I can vote, I have to tell Babylon in advance. I have to use my private key to generate those derivatives, which are called public and private randomness. They are public and private randomness pairs. And basically using the private randomness, I can sign data. And someone by the corresponding public randomness can verify that this data was indeed signed by me. So before actually voting, I have to tell Babylon in advance, okay, for the next 100 blocks, I'm going to use, for each different block, I'm going to use this public randomness. So for block 0, PR0, for block 1, public randomness 1, etc. And Babylon says, okay, noted. And then I can start voting. And for each block, I have to use the corresponding private randomness, the derivative from my private key. So what happens if I want to sign two conflicting blocks? I want to perform an offense. The protocol only allows me to use a particular private randomness. Otherwise, my vote is invalid. So I'm signing two conflicting blocks. The only way that I can sign two conflicting blocks is through the same private randomness. And if I do it, my private key is exposed.
Right. And because that implements the extractable randomness, extractable one-shot signature scheme.
Exactly.
Okay. So then you can prove that two blocks have been signed. So there was equivocation, right?
Yeah, exactly. We see two conflicting signatures. We don't even need to prove it. Like we can just extract the private key. So if I can, the fact that I extracted your private key is proof enough.
And then, so how does the link from the Babylon chain, once this is discovered, it's clear that the slashing must happen, right?
Mm-hmm.
So the private key that you extract is somehow connected to the UTXO on Bitcoin, or to the slashing path in Bitcoin, or how does that slashing path get activated?
So we know the UTXO because in order for the staking to become active, the user had to publish it. Like they had to let us know, okay, look at Bitcoin versus I have staked Bitcoin. So we know the UTXO, and anyone that sees these two conflicting signatures can extract the private key and go to this UTXO. I have the private key, so I'm that person. So I execute the slashing path.
Okay. So then you can essentially sort of even decentralize this function, right? There could be, is there some tiny reward for the person who actually executes this path to motivate them to go and commit the TX in Bitcoin?
Yeah, so we have developed a particular program for that, which is another program in our Vigilante series, which we call the Slasher. Currently, in the MVP, there are no rewards, but this can definitely happen.
Right, because that would then incentivize people to actually actively monitor the Babylon chain for any slashing events, and then go and do that on behalf of the chain.
Yeah.
They're opening this to sort of more cooperation. This is a very interesting construction. I think shoehorning staking into Bitcoin tech deserves kudos to you guys for working this out. It sounds like it was quite a technical challenge to get all these pieces together. So
thank you.
I'm curious how are there next protocols you guys are thinking about, or is this the focus for the foreseeable future? What are the things are on your mind for Babylon?
Yeah, so our goal is to launch a testnet in January. And then we are planning on, hopefully if all goes well, we want to release a mainnet in the first half of next year. And then there are some protocols that we want to touch upon. One of them is Bitcoin data availability, and the other one is a Bitcoin liquidity marketplace.
So can you explain what those are? So you want to use Bitcoin as a DA layer, but the data is not going to be stored on Bitcoin. So the Bitcoin is going to store some of the commitments, right? Or
that's the challenge. So we want to use Bitcoin as a data availability layer. The challenge is how to do this with the limited data storage that Babylon provides. We have recently seen some people use Bitcoin for data storage, like ordinals, etc. But these have unique properties and are using the taproot methods, which might not be exactly ideal for a data availability layer, as you need to reveal the stuff later on. Yeah, and the Bitcoin liquidity marketplace is pretty vague right now. This is our last goal, but basically bringing Bitcoin liquidity into the ecosystem.
So making Bitcoin available for arbitrary transactions inside, let's say, like on some Cosmos chain, like bring it to DYDX.
That would be the holy grail.
That would be the holy grail. That sounds like another worthy target for you guys to hit. So fingers crossed that you guys are successful and develop all those cool pieces of tech we've been talking about. And I want to thank you for coming on the podcast. This was super interesting to listen to.
Thanks a lot for the great discussion.